guys, cool. So now we're going to be looking into case 6, which is equations containing brackets. Cool. And it says when the equation contains brackets, we first use the distributive law to remove the brackets and then solve. Cool. And we've done the distributive law already, so we kind of know the vibe here. So what we actually have to do here is we'll have to multiply this 2 by this minus 3, and we'll have to multiply this 2 by this negative 5. We'll follow the BODMAS rules, right? Or BODMAS. I like to use BODMAS. And we'll do what's in the brackets, then of division, multiplication, then addition and subtraction. So we're gonna multiply those two first, do what's in the brackets, and we're gonna end up with 6x minus 10 is equal to 8. Then I'm going to carry this negative 10 over to the right side of the equation, and I'm going to get 6x is equal to 8 plus 10. So 6x is going to be equal to 18. And then I'm going to divide this 6 by 18, and I'm going to have 18 divided by 6. And 6 goes into 18 3 times, so x is equal to 3. Cool. So it's pretty simple. When it comes to case 6, guys, with brackets, make sure that you do the brackets first, follow the BODMAS rules, and then of course you solve for the unknown, which is x. Cool. All right, so let's move on to case 7. Okay, guys. All right, guys, so now we're going to be looking at case 7. And in case 7, we're looking at equations containing fractions. Cool. So we have one simple step here, right? Two steps pretty much. It says when the equation contains fractions, we first find the LCM of the denominators, then multiply each term by the LCM and solve. Cool. So that's really simple. Okay, guys, and let's just do that. So we're looking at this equation here. We have three fractions, and we need to find this unknown. Cool. So the first thing we need to do is find the LCM of the denominators, right? So we have 7, 5, and 5. So we're going to use the lovely method to solve for the LCM. And the LCM would be equal to, we're going to draw a little square table here. And we're going to have simply 5 and 7. Cool. And we always start off with 2. We're using the prime factors, 2, 3, 5, 7, 11, right? And we say, can 2 go into these two numbers? No, 2 can't go into them. Can 3 go into these three numbers? No, 3 can't go into them. Can 5 go into these two numbers? Yes, 5 can go into 5, leaving 1 here. And 5 can't go into 7, so we just leave a 7 here. Then we do the same thing. Can 2 go into these two numbers? No. Can 3? No. Can 5? No, but 7 can. So we're going to have a 7 here, and we're going to end up with 1 and 1, and that's it. So to find the LCM, it would end up being these two numbers multiplied by each other. So the LCM is equal to 5 times 7, which is equal to 35. Cool. So the next thing now we're going to do is multiply each term by the LCM and solve. So we're going to have x over 5 times 35 minus 3 over 7 times 35 is equal to 1 over 5 times 35. Cool. So this 5 goes into this 35 7 times, so you end up with 7x. This 7 goes into this 35 5 times, so you end up with 5 times 3, which is negative 15. And then you're going to end up with 5 into this 35, which gives you 7, which is 7 here. We can move this 15 to the right side of the equation, and we get 7x is equal to 7 plus 15. And then we're going to have 7x is equal to 22, right? Yeah, that's exactly what we get. So now we can just solve for x, right? That's all we need to do. And when we solve for x here, we have x is equal to 22 over 7, right? Yes, x is equal to 22 over 7. So that's pretty easy. If you want to write it in decimals, you can write it in decimals, but I think I'm going to leave that as a fraction there. So x is equal to 22 over 7. And we can just move on. We can move on now. We're going to look at two more examples with fractions. Okay, guys? All right, guys, great. So we're going to look at these examples here with the fractions. And the first thing we need to do for this one, guys, for number 2 here, is to find the LCM. So we have 4, 5, and 8. 4 is written twice under there. So we're going to have 4, 5, and then we'll have 8. Cool. And we'll draw our little table, of course. And then, of course, we're going to use the prime factors 2, 3, 5, 7, and 11. And then the first thing we're going to do is say, can 2 go into both of 3 of these numbers? Yes, 2 can go into 4, leaving 2, and 2 can go into 8, leaving 4, right? And we end up with 5 remaining the same. And then we say, can 2 go into any of these? Yes, 2 can go into 2, leaving 1, and 2 can go into 4, leaving 2. And the 5 remains the same. Can 2 go into any of these? Yes, 2 can go into that 2, leaving 1, leaving 5, and leaving 1 here as well. Then can 2 go into 1, 5, or 1? No. Can 3 go into 1, 5, or 1? No. Can 5? Yes. 5 can go into that 5, leaving 1, 1, 1. And when we're finished, we always finish when we have this 1, 1, 1 here. So the LCM is equal to 2 times 2 times 2 times 5, right? Which would be 8 times 5, which is equal to 40. Cool. So we're going to multiply everything here by 40. So it's 7 over 8. 7 over 8. So it's 7 over 8 here. 7 over 8x multiplied by 40. This 8 goes into 40 5 times. So we're gonna end up having 7 times 5, which is 35x. 35x minus 40 times 1 over 4. So this would end up being 4 goes into 40 would be negative 10. Then this is equal to 4 over 5 times 40. This 5 goes into 40 8 times, and then 8 fours, well, yes, it should be 32, and then plus 11 over 4 times 40 would be equal to 4 into this is 10. So 10 times 11 would give us 110, so this would be plus 110. All right, so that's a lot of numbers, guys. So we're going to end up with 35x. 35x is equal to, this 10 is going to go over to the right side of the equation, and we're going to end up with, oh, hold up, guys. This is actually 4 over 5x. Remember the x was here, multiplied by the 40. So 5 goes into the 8 would give me 32x plus 110, right? So let me just remove this here. This would actually be 35x minus, I'm going to carry this over here as 32x. Then I'm going to get 110 plus 10, which would give me 3x is equal to 120. So all I have to do now is divide this 120 by 3, and then x would be equal to 40. Cool. So that's our answer. X is equal to 40. All right. So let's do the same thing for here, guys. For number 3 here, let's find the LCM. And the numbers are 9 and 9 duplicated twice, so it's just 9 and 3. And we're going to draw a little table, of course. Then we're going to use the prime factors 2, 3, 5, 7, 11. And can 2 go into these? No, but can 3? Yes, 3 can go into both of these, leaving 1 and 3. And can 2 go into these? No. Can 3 go into both of these? Yes, 3 can go into 3, leaving 1 and 1. And we're going to end up with the LCM being 3 times 3, which is equal to 9. Cool. So we're going to multiply everything here by 9. So we're going to have 4x over 9 times 9. These two 9s cancel, giving us 4x. Then we're going to have negative 3x plus 2 over 3 times 9. This 3 goes into this 9 3 times. So we're going to end up with this negative 3x minus 2 times 3. So we're going to end up with negative 9x, right? Minus 6. That's what we're going to get for this here. And then this is going to be equal to 4 over 9 times 9. And this 9 will cancel this 9 equals 4, right? Cool. So we have a pretty strange situation here. We have this being negative we're going to end up with a negative 5x, negative 5x. And I'm going to carry this, yeah, negative 5x minus 6 is equal to 4, right? And if I carry this negative 6 over to the right side, I'm going to get negative 5x is equal to positive 10, right? And then x is going to be equal to 10 divided by minus 5. And when you divide by a negative, guys, you get a negative. So this is going to be minus 2. X is equal to minus 2. And that's the answer. Okay. Cool. So the answer is, let me just write the answer down here. X is equal to minus 2 for number 3. Cool. All right. And these are pretty much all the 7 cases, guys. Cool. So we're finished. We finished this video, guys. And now we're going to move on. Yeah, let's clear the screen. And now we're going to move on to inequalities. All right, guys. We're going to move on to inequalities. Cool. So I'll see you in the next video. Have a wonderful day, guys.